Hello, my name is Kevin Stamp from PS Motion. In the last video I showed you how to add a simple crank slider mechanism. Now we are going to add a cam. This is the mechanism we built in the previous tutorial, part 1. In this tutorial we will change the motion of the crank. Rather than let the crank rotate continuously, we will move it with a motion. We will use the default motion in MotionDesigner, which we can see over to the right. We need to link the motion to the crank. To do this, we must add a new function block, which we call a motion function block. To add it to the graphic area, we click the icon in the kinematic function block toolbar, and then click the graphic area. The motion function block has an input connector and an output connector. We should think of the input connector as the x-axis of the motion, and the output connector as the y-axis of the motion. We can see in MotionDesigner that the x-axis has a range of 0 to 360. We need, therefore, 0 to 360 at the input connector of the motion function block to get the motion described by the y-axis of the motion at the output connector. The linear motion function block has a range of 0 to 360, which is the same as the x-axis of the motion. Therefore, we can connect a wire from the linear motion function block to the input of the motion function block. When we do that, the output from the motion function block will be the y-axis of the motion as we see in MotionDesigner. We must also connect a wire from the motion function block to the input of the motion dimension function block, as this is the function block that controls the crank angle. A function block can only have one input, therefore we need to first delete this wire. And then connect the wire from the motion function block to the motion dimension function block. Now, when we cycle the mechanism, we can see the crank rocks or oscillates back and forth. The angle it rotates is the same as the y-axis of the motion in MotionDesigner. The starting angle of the crank is set in the motion dimension dialog. In summary, the flow of motion values is, from the linear motion function block, we have 0 to 360. The input to the motion function block is therefore also 0 to 360. This represents the x-axis of the motion in MotionDesigner. The output from the motion function block therefore represents the y-axis of the motion as we see in MotionDesigner. The input to the motion dimension function block is therefore also the motion as we see in MotionDesigner. The starting angle of the crank is set by the motion dimension. We may edit this later. We now need to add a cam. We will put the cam on a rotating shaft. These steps are identical to the steps we did to add the crank in part 1 of these tutorials. First, we need to add a line to the base part so that we can use the point at the end of the line to locate the center of the camshaft, and the line itself as the reference for the rotating angle of the camshaft. We edit the base part, add a line, dimension it like before. Now we add the part for the camshaft. We join it to the point at the end of the line with a pin joint, and finally add the motion dimension function block. It needs to rotate at constant speed, so we connect a wire from the linear motion function block to the input of the motion dimension function block. Now, when we cycle the model, we can see the crank rotates one time for each motion cycle of the rocker. We need to add a cam follower. In this case, we add a roller to the rocker that has the motion. In exactly the same way as we used the part editor to edit the base part when we added a line, we use the part editor to edit the rocker to add the roller. This time, to edit the rocker, we will use the selection window. We click the part outline to select the part, right-click the part in the selection window, and click Edit Element. The roller is circular, and thus we add a circle. We add its radius with the Add Dimension tool. We also locate the center of the circle with dimensions. When we have done that, we exit the part editor to return to the mechanism editor. We click this icon. The cam follower needs to be a profile. We use Add Profile from the Solids toolbar, then click the circle and click OK in the Command Manager. We can see the roller now looks pink. This is the default color for the profile element. Now we can add the 2D cam. We click Add 2D Cam from the Machine Elements toolbar. We need to select two elements, the part that identifies the cam and the profile that identifies the follower. Click the part outline of the camshaft, and then click the pink profile of the follower, and finally OK in the Command Manager. We can see the cam profile immediately. When we cycle the model, we can see the follower remains in continuous contact with the 2D cam. Here, I've just changed the color of the background and the color of the cam to help you see the cam more clearly.